Pardon? Okay, I'll wait a minute. But just before we start, a little plug. There's now a Facebook page for IO, so you can like the Facebook page and get updates when I update the blog and when I post lecture slides. So it's facebook.com/surreyio.
But Raj always walks and he went to the island. And they did the tutorial this morning at 10, so I don't know why they would be here. They did it for another part. I don't know
You want to? Yeah.
Okay, should we start? This is probably about everyone. So we finished the lecture, and we didn't quite get a chance to do this. Some seats around the side. We'll be in a bigger room for other classes. It's just that I had to rearrange this one last minute. So. I was talking to the European Commission on Tuesday. Big wigs, pretending I have some influence in the world. Yeah, okay, so we finished the lecture with this question about isoelastic demand. How does a monopolist price when there's isoelastic demand? Okay, so I'll just write it up and we'll go on. So we had the demand curve B equals and we had linear costs. Okay, so that was the demand curve we had. The monopolist had this total cost function. Okay, so this is total cost, so what's marginal cost? C1, yeah. Okay, so we understand total cost and marginal cost. So did anyone have a go at this? Have a go at working out the monopolist pricing? Yeah, a few people. Does anyone want to volunteer to have a go on the board? You did? Really? If you don't want to, you don't have to. If you're feeling brave. No? Go on, you clearly want to.
Not really?
Yeah.
I won't go, right.
Okay. So, you know, it's good if you're brave and have a go at doing these things, because everyone makes similar mistakes. So you'll learn a lot from seeing the mistakes that other people make. So, you know, even if you don't know the answer, come and have on the board and have a go, because it'll help you and help everyone. Okay.
So you have the profit, which is PQ times Q minus cost.
Yeah, so profit is price times quantity minus cost.
Which is K Q to the minus beta times Q minus I should do the brackets, yeah. And that is
yeah, so when you have, this is like q to the power of 1. When you have q to the power of a times this is q to the power of b, that's like q to the power of a plus b. So this is 1 minus b.
And the monopolist maximizes profit and quantity. So you differentiate.
So that's 1 to
Yeah. Which is 1 minus beta K Q minus beta minus C1, and that equals to 0.
Yeah, okay, so we found profits. It's always the first thing you do with these problems. Then the monopolist is trying to maximize profits, so ideally when you're writing an exam answer, you write, the monopolist maximizes profits, at a maximum, the derivative is going to be 0. So this is what's called the first order condition. Okay, so we differentiate profits. Here, so this may be obvious for you all, but this is the rule when you have the derivative of x to the n, that's n x to the n minus 1. Okay, derivative of x to the n is n x to the n minus 1. Okay, so that's the rule we've used here. And then derivative of c1 times q is easy.
So then, what do we do now? You have to put everything in terms of q to get the quantity that the monopolist would offer. So we move C1 to the other side and divide through by this.
Okay.
So the way I did it is 1 over QB. Yeah, equals C1.
Okay, can I?
Should I do an intermediate step?
It's fine. You've done the hard part.
Okay.
There's a slightly faster way to do it.
Okay.
Okay. So what we've got here is k times q to the minus beta, and look at price. Price is k times q to the minus beta. So this is just 1 minus beta times the price minus c1 equals 0. Okay, so add c1 to both sides. So 1 minus beta times the price is equal to c1. So the price is equal to c1 over 1 minus beta. Is that the right answer?
Yeah.
So, always the trick with these isoelastic demand curves is that you're always going to get to a point where you see the demand curve appearing in your expression, and then you just substitute back in for the price. Okay. I'm sure it's basically the same as what you did.
Yeah, but then I substituted back into this equation, and then I got the same quantity.
Yeah, I'm sure.
Yeah, or price. Yeah.
Okay, so the nice thing about you can sit down.
Yeah.
Thank you. The nice thing about these isoelastic demand curves is that you're getting markup pricing. Okay, so C1 is marginal cost. They're setting a price which is something times marginal cost. Okay, so the gross markup here is going to be 1 over 1 minus beta. So gross markup is price divided by marginal cost. Okay, markups are normally denoted by mu. Okay, so mu is price over marginal cost, which here is equal to 1 over 1 minus beta. So with beta, I haven't made a mistake, have I? No? Oh, okay. With beta between 0 and 1, so beta is between 0 and 1, this is something between 0 and 1, okay? So dividing by something small is going to give you something big, right? So as beta gets closer and closer to 1, this is getting closer and closer to 0, so the price is going to infinity. So as beta gets to 1, they want to set progressively larger and larger markups until eventually when beta is equal to 1, they want to set an infinite price. Okay, so for this to make sense, we have to have beta less than 1. So if the demand curve is too inelastic, demand is very inelastic, that means monopolists just want to set higher and higher prices, and eventually if demand is sufficiently inelastic, they want to set an infinite price. Okay, it's like your demand for one slice of bread a day or a glass of water a day. You know, there's going to come a point if you're starving in a desert, your demand for a glass of water is going to be very inelastic. You're going to be prepared to give anything for this glass of water because if you don't have it, you're going to die. So with very inelastic demand, a monopolist wants to set a very high price. Okay, so is this clear to everyone? So this is the important trick, right? This substitution. So we got that, and we replace it by the price. And we're going to do lots of things with isoelastic demand, and you're always going to be using a trick like that. And then in the question I asked for, come on, some seats over there. Well, first, so this is the price. What's the quantity going to be? How would you find the quantity? So we just substitute into the demand curve. Okay, so if we've got the price is equal to C1 over 1 minus beta, but we know that the price is equal to K times Q to the minus beta. Okay, so you divide by K, so 1 over K times C1 over 1 minus beta is equal to Q to the minus beta. Okay, let's get rid of this minus sign. Okay, so raising to the power of a negative number is like 1 over. So this is the same as 1 over Q to the beta. Okay, so then we can invert both sides of this equation. Let me go up the top here. So this is saying that we just invert both sides. K times 1 minus beta over C1 is equal to Q to the power of beta. And then to get rid of a power of beta, we're going to raise both sides to the power of 1 over beta. Okay, so it's not particularly nice, but K times 1 minus beta all over C1 to the power of 1 over beta. Okay. So well, we can have a look at this makes sense. Okay, so here's the quantity. As K increases, K is like a measure of how much is demanded at any price, right? The higher K is, the higher the demand curve is, the more people want at any price. So as K increases, the monopolist provides more quantity because people want more. As marginal costs increase, the monopolist produces less. That makes sense as well. And then the effect on beta is a bit messy. No, so this is decreasing. 1 minus beta is decreasing in beta. This is decreasing in beta. So all of this is going to be decreasing in beta. Okay, so as demand gets more inelastic, so as beta gets close to 1, the quantity gets smaller and smaller. Okay, so when we said that when beta goes close to 1, the monopolist sends the price up to infinity, but they're also going to be supplying less and less quantity. And this is obvious because in order to put, people don't, at a very high price, people don't want to consume very much. Okay, so if a monopolist is sending the price to infinity, they have to be supplying a very small quantity. So as beta gets close to 1, the price goes to infinity and the quantity goes to 0. And you can plug in and look at what profits are doing. So here was our expression for profits, what we had before. So let me okay, so this was profits. Let's see what happens to profits as we play around with different parameters. Okay, so it's not going to be particularly nice. So this thing here, we know is let's go from the very top actually. Start with a minute. So we know what the price is, right? We have this nice expression for the price. So let's plug in the price. So price is C1 over 1 minus beta times quantity minus total cost, which is minus C naught minus C1 times Q. Okay, so this is a bit nicer expression to work with. So we can collect these two terms together. Okay, so this is C1, we've got a C1 here and a C1 there, times 1 over 1 minus beta minus 1 times Q minus C naught. Okay, so this was the gross markup, price over marginal cost, 1 over 1 minus beta. So this, the gross markup minus 1 is a kind of net markup. Okay, so the gross markup would be something like 120% if the price is always 20% above marginal cost, and net markup would be the 20%. Okay, you're setting kind of extra 20% above the marginal cost. And you can simplify this a bit. So just to remind you how you go about simplifying fractions. Again, I know it's a long time since you did any maths. Okay, so the trick is to express both sides in terms of the same denominator. Okay, so 1 over 1 minus beta minus 1, well that's equal to 1 over 1 minus beta minus 1 minus beta over 1 minus beta. Yeah, because 1 minus beta over 1 minus beta is equal to 1. So what do we have here? Well, we can now put all of this into one fraction. Okay, so that's 1 minus 1 plus beta all over 1 minus beta. 1 minus 1 cancels. Okay, so that's beta over 1 minus beta. I'm confused. It's a bit messy, this board, I'm afraid. So, you know, I'm just going through these little mathematical tricks because it might be a while since you've done them. Okay, so these simplifications might help. So we can plug this in to here. So this is just C1 times beta over 1 minus beta times Q minus C naught. Okay, so profits are going to be just increasing in quantities once you substitute it in. And we have this expression for the optimal quantity. So, in fact, as beta goes, well, let's look at what happens as k changes to start with. So k is shifting demand. If k goes to 0, that means there's no demand for the product, right? This was our demand curve. So k goes to 0. It's like they're prepared to pay a price of 0 no matter what the quantity is. So k goes to 0, q goes to 0, profits go to 0, or minus C naught. So that makes sense, right? Now what happens as beta changes? Okay, so remember, as beta increased here, q was going towards 0. Okay, beta gets bigger, this gets smaller, all of this gets smaller. Okay, so as demand gets more inelastic, quantity is going towards 0. But then we've got this expression here, which is beta over 1 minus beta. So as beta goes towards 1, this is going to 1. 1 minus beta is going to 0, so this thing is going to infinity. So you've got this thing which is going towards infinity, okay, and this thing which is going towards 0. So it's not immediately obvious whether this thing is going to be increasing or decreasing as beta goes up. You could, so if you wanted to do it properly, you could differentiate these things to see, but it's just kind of intuitive that in fact this whole thing is going to be increasing. So if you like, when beta's close to so one way to say it is when beta's close to 1, 1 over beta is going to be approximately 1. Okay, so it's like you're multiplying by 1 minus beta. Okay, So it's like you've got a 1 minus beta here. Okay, so you've got a 1 minus beta on the bottom, 1 minus beta on the top. Those kind of cancel out, and what you're left with is the beta effect. Okay, so as beta increases, profits are going to increase. Okay.
So, what are we trying to show in markup pricing? I didn't.
So the exercise was just, this was the important thing to prove in the exercise.
You mean the first part?
Yeah.
The other dot that says markup pricing is just to explain that.
So this is markup pricing because the price is set as something times marginal cost. Okay, so this is what we found optimally. C1 is marginal cost, so the price is something times marginal cost. And then this stuff about what happens to profits as beta changes, that's just for your interest, right? Okay, it's just to help understand what's going on with isoelastic demand. Okay, so the question asked, if you remember the question, we looked at linear demand, and for a linear demand we asked what consumer surplus, producer surplus, and deadweight loss were. So working out profits, which was this expression, profits are producer surplus. So this is like working out producer surplus for isoelastic demand. Okay, and you could do working out consumer surplus would be a bit harder. So we're going to skip that for now. And then in the further problems slide, I asked, we do the problems on the previous slide assuming the monopolist chooses prices rather than quantities. Okay? And you're going to get exactly the same answers. Okay, I'm not going to go through that here. It doesn't matter if the monopolist chooses prices or chooses quantities. It's still going to be, the same thing is going to be optimal. It's just a change of variables, right? So the important thing is how we derive this. Does anyone have anything else they'd like to talk about with isoelastic demand? Queries? Okay, then for a few exercises in the book that I suggested you have a look at. So, which of these exercises did people try, if any? Stunned silence. Does that mean none? Okay, well. Okay. There's a new, I saw the shop has an Amazon locker now, so now maybe you can get things from Amazon quicker. And Amazon have this Amazon student thing. You get 6 months of free Amazon Prime from Amazon Student. You can get next day delivery for free. It's quite a good deal, actually. I pretend to be a student in order to get it. I'm not getting paid by Amazon. Okay, so we had, it was exercises 3.4. The first one, well, this one you can do without even doing any maths at all. So this is very easy. So this is a production function. Quantity produced is labour plus the square root of capital. And the question was, does this exhibit increasing returns to scale, constant returns to scale, or decreasing returns to scale? And you don't really need to do any maths to tell me the answer to that. Maybe you didn't read the... So returns to scale is just if you double the inputs, you get double the outputs. So if If you double the inputs and you get double the outputs, that's constant returns to scale. If you double the inputs and you get less, that's decreasing returns. If you double the inputs and you get more, that's increasing returns. It's decreasing, yeah, exactly, because of its square root. Okay, so that was very easy, that exercise. The next exercise was, again, about cost functions. So it said, consider the cost function, what was it, C of Q equals F plus CQ. So this is a capital C. So this is a total cost function. There's a function of quantity, there's an F and a C bit. And it says calculate and plot the total cost. Okay, and it says F and C are both positive. Calculate and plot the total cost curve, average cost curve, and marginal cost curve. Does someone want to volunteer to do this? Even if you haven't done this exercise, it's easy, right? So what do these graphs look like?
Can I say it from here?
Yeah, go on, okay. You tell me what to draw and I'll draw. So
average cost is, we should divide by Q, so
yeah.
it's should be decreasing.
Q over Q. Okay. So divide by Q.
So it's decreasing as Q is increasing.
Okay.
So it's a downward.
So what's it give me? F over Q plus C.
So it's a constant. Yeah.
Okay, so something like that.
Yes. Marginal cost. It's C. It's the derivative of CQ. So
Yeah, exactly.
it's constant. Yeah.
So this is marginal cost.
And total cost should be increasing.
Yeah. So total cost is what we started with.
With yes.
So I'll draw this on a different line, and this is going to be F,
Yes.
and it's going to be a straight line. Okay, so that was easy. What output level is the average cost minimized?
Will it be wrong, by the way, to put in the same graph? No, right?
You could put it in the same graph. It's just so this is, if you like this, it makes sense to split it like this because this is about cost per unit and this is total cost. So so average cost is converging to marginal cost as quantity increases. So it makes sense to split it. What output level is the average cost minimized? Well, you can see this just from looking at the graph. It's going to be minimized when Q equals infinity. Okay, well, as quantity gets bigger and bigger, average cost is falling. Okay, and then the final part of the question says, does this technology exhibit increasing returns to scale, constant returns to scale, or decreasing returns to scale? Someone else want to do that? Go on, you're muttering.
No, I'm just thinking.
You're just thinking. Well, is it constant returns to scale? If you so with constant returns to scale, what do you know about the relationship between average cost and marginal cost?
It should maintain the same.
Yeah, exactly. So constant returns to scale means average cost and marginal cost are going to be the same. Okay, you produce an extra unit and it's not changing the cost of producing another unit. Whereas here, average cost is declining. So does that mean?
Increase.
Or
The other?
or decreasing returns to scale. So no, sorry, you're right to start with.
You get more.
You get more
Yeah,
because the cost is
yeah,
going down each time.
Yeah, sorry, you're right to start with. I'm half asleep. So you know, the cost function, you can think of it as like a fixed cost. So this is the cost of starting your factory to start with, and a marginal cost. And as you're producing more and more, the fixed cost is a smaller and smaller quantity. So it's like you're getting, the fixed cost is kind of getting smaller as you get bigger. Okay, so this is like an increasing return. Yeah, sorry. Yeah. So this is increasing returns to scale. Okay, because you're getting rid of this fixed cost effectively. So what was next? 3, 4, 5. So the next question said, consider demand function 99, Q is 99 minus P. Okay, and this is about elasticities. Okay, so it says, at what output level does the elasticity equal minus 2? So let's just remind ourselves of the definition of an elasticity. So, what's the definition of the elasticity? Anyone remember?
dq dp
dq dp
times p over q.
Okay. So yeah, so it's a percentage change in quantity for a percentage change in price. So for this demand curve, well, dq dp is going to be minus 1. Right? We change quantity, it's minus 1 times p over q. So then substituting in for q, this is minus p over 99 minus p. Let's get rid of a minus sign, so this is p over p minus 99. Well, that's bad. It's kind of it was. So minus p over 99 minus p. So what output level does the elasticity equal minus 2? So for this thing to be equal to minus 2, we must have p over 99 minus p is equal to 2. So this is just a linear equation, isn't it? So p is 99 times 58 minus 2p. Okay, so take 2p over to the other side. Oh, very boring. What?
66.
66. Okay, you're ahead of me. That makes sense, doesn't it? 60. Good. So the next part said at what output level does the elasticity equal minus 1? You know, it's going to be the same method, so we're not going to do that. Then it says calculate marginal revenue. Okay. So what's marginal revenue? What's the definition of marginal revenue?
Differential total revenue.
Okay, what's total revenue?
Price times quantity.
Yeah. Okay. So marginal revenue is the derivative of price times quantity over quantity. Okay. So this is the derivative in terms of quantity of price. So let's invert the demand curve to start with to make things easier. So if Q is 99 minus P, then what's P? Yeah, exactly, 99 minus Q. So you add P to both sides, subtract Q from both sides. So we want the derivative of price times quantity. So here we've got an expression for price. Okay, it's 99 minus Q times quantity. So this is our total revenue. We're getting marginal revenue. There are two ways you can differentiate expressions like this. One way is just to multiply out the brackets. The other is to use the product rule. Let's do it with the product rule this time, so you got to remind yourself how that works. So the product rule says the derivative of u times v with respect to x is the derivative of u times v plus u times the derivative of v. I remember my A-level maths formula book had that in and have it into my mind. Okay, so what's the derivative of 99 minus q? Minus 1, yeah. So this is minus 1 times q plus 99 minus q times the derivative of q, which is, yeah. Okay, so this is 99 minus 2q. We've got a minus q there, we've got a minus q there. So that's our marginal revenue. And it says, at what output level does marginal revenue equal 0? So it's going to be 99 divided by 2, right? That's easy. And then the final part of the question is about consumer surplus. Okay, so remember we've got price, quantity, some demand curve. Okay, so here's our demand curve, so this is 99, and this is 99. And it says consumer surplus when P is 33, and P is 66. Okay, so here's P is 33. So, which bit is consumer surplus? Something different.
The triangle.
Okay, the triangle. Yeah, so this is consumer surplus. So what's the area of that triangle? How would we find the area of the triangle? Yeah, exactly. You know, so the area of a triangle is half the area of the square. Okay, so the square, if this is 33, this is going to be 99 minus 33, so this is going to be 66. So this is 66, that's 66. So consumer surplus here is going to be 66 times 66, all divided by 2. It's all very easy, isn't it? What are we doing? And then the last question from these exercises 3.4 was about isoelastic demand. Okay, so this is another good opportunity. Okay, so the first part of 6 we did in the lecture. So it gave you an isoelastic demand curve and it asked you to invert the isoelastic demand curve. So we did that in the lecture. And then it was talking about elasticities. Yeah, so let's skip that because we basically did it in the lecture. Okay. So is everyone happy with these exercises? They don't seem too hard, right? You know, it is important that you have a go at doing the exercises. If you do the exercises, you're going to find the exam quite easy. The best way to get good at this stuff is just practice, practice, practice. Okay, so these exercises, the exercises in chapter 3 were about costs and production functions. Exercises in chapter 5 are about monopoly. Okay, so I asked you to have a go at exercises 1, 2 and 7. So did anyone have a go at exercise 1? Someone want to do it on the board? And I'm sure you did, but what about you? No? You volunteering? Charlie? No? What about, you must have done it, you're a hard-working student.
Haven't got the book yet.
Bad excuse. You can probably find it online.
I did, but the delivery man didn't knock on my door.
No, I mean you can probably find it for PDF online if you...
I tried looking at kind of only found the answers.
Is it on torrent?
And you can't torrent on the university.
Oh.
Okay.
Unless
You
you're
have
like
limited
50
options.
Have they actually?
Yeah.
Oh my goodness.
Okay, well... So in fact, so 5.7 exercise 1 was exactly what we did at the start of the lecture. Okay, so it's isoelastic demand. What happens as the elasticity changes? So what happens to the monopoly's price as beta goes to 1 is one of the questions. Okay, so we've done all of that already. Yeah, we've done. So that's we've kind of done that. So let's have a look at exercise 5.7 question 2. Okay, so this question says, consider the market for G jeans, the latest fashion amongst people in their late 30s. G jeans are sold by a single firm that carries the patent for the design. On the demand side, for NH high-income consumers who are willing to pay a maximum amount of VH for a pair of G jeans. Okay, so we've got NH rich people who want to pay VH, are prepared to pay up to VH, and we've got NL low-income people, NL low-income people who are willing to pay a maximum amount of VL. Okay, so it's like, you know, you've got 10 people who are prepared to pay up to £100 for a pair of jeans, another 20 people who are prepared to pay up to £40 for a pair of jeans. And we're assuming that VH is bigger than VL is bigger than 0. Okay, so rich people are prepared to pay more than low-income people for these jeans. And assume that each consumer buys only one pair of jeans. And then it says, suppose that G Jeans Monopoly cannot price discriminate. That means that it can't charge a different price to the two markets. Okay, if you go into Debenhams to the Levi's store, you know, the staff, the guy at the counter doesn't look at you and say, you look rich, I'm going to charge you £100. You look poor, I'm going to charge you £40. Charge at the same price to everyone. So they can't price discriminate, and is therefore constrained to set a uniform market price. So first part of the question is, draw the market aggregate demand curve facing the monopoly. So this is a bit like something we did in the lecture. Remember we showed how you could create an aggregate demand curve from lots of individual demand curves. So does someone want to have a go at drawing this demand curve? And you were shaking your head very vigorously.
Sorry.
Come on.
No, like I haven't done it. Sorry.
You were bowing your heads. Come on, somebody volunteer. Is that... Yeah, okay, well I'll take that. It's really the best I'm going to get. Okay, so we've got, this is quantity, this is price. So, which square are we going to draw first? The high income consumers or the low income consumers?
Low income consumers first.
High. I prefer high. So we've got NH high income consumers, and they're prepared to pay up to VH. Okay, so this kind of gives a chunk of demand like that. And then additionally, you have these NL low income consumers who are prepared to pay VL. Okay, so this point is going to be NH plus NL. So this distance is NL. We've got NL extra people willing to pay. and they're prepared to pay up to VL, so let's draw a VL here. Okay, so you're going to get a chunk of demands like that. So this is our demand curve. Then it says, find the profit maximizing price set by G genes considering all possible parameter values of NH, NL, VH, and VL. Assume that production is costless. Okay, so it's a little bit tricky. Did anyone have a go at this?
Would you just sum the area on the ranges, sort of sum the area under both squares, and see whether that's greater than like them individually?
Yeah. Yeah, that's the idea.
Because that's produce a surplus.
Yeah, exactly. So yeah, so profits are normally, yeah, you're right. So profits are normally price times quantity minus total cost, right? The total cost here is 0. So profits are just price times quantity. Here we've got price, here we've got quantity. So these are potential chunks of producer surplus that the monopolist can get. Okay, so if he chooses a price between VL and VH, then he's going to be selling to the high-income consumers but not selling to the low-income consumers. So if he's going to choose a price between VL and VH, he may as well choose a price of VH. There's no point pricing below VH. Okay, if you price below VH, you're just throwing away producer surplus. Okay, there aren't any extra consumers who are going to buy because you're setting a slightly lower price. So you might as well set a price of VH if you're going to sell to both. So one option that the firm can do is you can set a price of VH, and then the producer surplus is going to be this chunk here. Okay, the low-income consumers aren't going to buy at all. The other thing he can do is to set a price of between 0 and VL. Okay, if he sets a price between 0 and VL, he's going to get this square and kind of sum of this square as well. Okay, and again, just as before, there's no point setting a price less than VL, because if you set a price below VL, you're not getting any extra consumers. So you might as well set a price of exactly VL. Okay, so in this other possibility, he's going to get this area. So this little square plus that big square. So, so if you like, the monopolist has two strategies. Okay, so strategy 1 has P equals VH. Strategy 2 has P equals VL. And what are the profits in both cases? Well, with strategy 1, the profits are this big square. Okay, so that's NH times VH. NH times VH. With strategy 2, the profits are this area here. Okay, so this is NH plus NL times VL. So NH plus NL times VL. So then the monopolist is going to choose whichever of these gives high profits. So all you have to do is see when this one is bigger than that one. Okay, so this one is going to be bigger than that one if NH VH is bigger than NH plus NL times VL. Maybe we can simplify a little bit by collecting all the NH's. Okay, so let's subtract NH times VL from both sides. So that's NH times VH minus VL. Has to be bigger than NL times VL. Okay, so there's some intuition we can get out of this equation, right? This is the difference in the prices that the high and low consumers are prepared to pay. This is the number of high consumers. So this is, if you like, this is the value gained by, this is this area, okay? It's the value gained by selling to the high consumers at the high price rather than at the low price. Okay, it's the extra profits you get from selling to the consumers at the high price rather than low price. This is the profits you get from selling to the low consumers. So, if you like, this is saying that this square has to be bigger than this square. So if this square is bigger than this square, then you want to set the high price, otherwise you want to set the low price. Okay, so the way I've drawn it you'd want to set the low price. It's like you always get this square, okay? You're always getting the value you get from selling to the high consumers at the low price. If you choose the high price, you're also getting this square, which is the value of selling to the high consumers at a high price. If you choose the low price, you get this square, which is the value of selling to the low consumers at a low price. Yes, it's just a question of whether this square is bigger than that square. So as I've drawn it, you'd want to set a price of deal. So this selling to different markets is something we'll be talking a lot about later on in the course. Okay, so here the firm was constrained to choose the same price in both markets. Okay, but in real life, often firms can price discriminate a little bit. If you go into GBK, show your student card, you get 40% off, which is, crazy discount. So here, GBK, if you like, is price discriminating. GBK is saying, look, students are less well off than everyone else, so let's give students a good discount. Okay. And GBK don't realise that staff university cards aren't student cards. Okay, so we'll be talking more about this later in the course. What else did I ask? Question 7 was the final question I asked you to have a look at. Okay, so final question, then I'll let you go. So it says the monopolist is facing a downward sloping linear demand curve. P is A minus Q. And they've got a unit production cost of C positive. Okay, so when a question says they have a unit production cost of C, that means constant marginal cost of C, or a total cost function of the type C times Q. Okay, let's make that. So capital C of Q is little c times B times Q. Okay, so we know how to do linear demand monopoly problems. There was a little twist to the question. It says, now suppose that the government imposes a specific tax of $T per unit on each unit of output sold to consumers. And it says, show that the tax imposition would raise the price paid by consumers by less than T. Okay, so the tax is on. Okay, so what's going to be not a very well written question. So this is the demand curve that consumers have. Okay, so if there's a tax, it's like the consumers end up paying more than the price that the firm is charging. Okay, so the tax, if you like, is going to shift the demand curve here. Does that make sense? So let's have a different letter for. So let's say okay, let's say little t is total cost. Okay. No, actually. Okay, let's have the price. So the price paid by consumers. That's going to be price set by the firm, which we're going to call F, plus the tax. Okay, so the firm is going to set a price F. The government is going to come along and charge you a tax T. So the total price paid is going to be P. Okay, so suppose this is how it works. So let's plug that into the demand curve. So it's like we've got F plus T is equal to A minus Q. So the demand curve faced by the firm is F equals A minus T minus Q. Okay, so the tax is shifting the demand curve that the firm faces. So as far as the firm is concerned, this is the demand curve. Okay, but in fact, you know, it's because the government is coming along and charging this tax. So then what happens when we maximise profits? Well, this is going to be standard. Okay, so profits are going to be price times. So here the price set by the firm we're calling F, which is so price times quantity minus costs. Okay, which was C times quantity. Okay, so what's the derivative of profits with respect to Q? Okay, well, here we have A minus T minus Q times Q minus C of Q. Okay, I'm going to go quickly now. So, using the product rule again, this is minus 1 times Q plus A minus T minus Q times 1. Okay, minus C. So this is A minus T minus 2Q is equal to C. So let's take C over to that side, 2Q over to this side. So Q is going to be equal to half of A minus T minus C. Tell me if I've made a mistake. And then we want the price. Okay, so this is the quantity. So we can plug that in to get the price set by the firm. Okay, so this is F is A minus T minus Q, which is A minus T minus half A minus T plus half C. You see what I've done? So I've split these brackets in two. Okay. So this is A minus T minus half A minus T. It's just going to be half A minus T plus half C. So that's the price that the firm is setting, and then the price that the consumer is paying is for F plus T. Okay, so P is going to be this plus T. Well, we've got minus half T. We're adding T, so then it's like plus half T. So P is going to be half A plus T plus half C. Okay, so what's happened with this tax? Well, it's kind of been split equally between the firm and the consumer. You know, the consumer is paying half. So, you know, if the tax was £1, the consumer's paying an extra 50p. And the firm is getting 50p less per unit that they sell. So it's like the tax has been evenly split here between the firm and the consumer. And the question that we were asked to solve was show that this tax imposition would raise the price paid by consumers by less than T. Okay, and we saw that. It's gone up by half T, not T. So when there's a monopolist, you impose a tax on the good, tax kind of gets shared between the consumer and the producer. And then it says, would your answer change if a market demand curve has a constant elasticity? And we don't really have time to go through that. So maybe you can have a guess though. So if you had an isoelastic demand curve, what would happen? So, you know, suppose you had this, P is Q to minus a half. So, P is F plus T. So the demand curve placed by the firm is now the form F equals Q to the minus a half minus T. So what does that look like? So before, an isoelastic demand curve looks like that. We've now shifted it down. Like that. I don't know. I think you have to do the maths. It's not obvious to me. Yeah. Okay. Without doing the maths, I don't know. I'm afraid. Yeah.
Yeah, because that's it. Try to catch up.